Welcome to the Explainer. Today we're diving into a really interesting question. Why doesn't the AI on your phone actually get any smarter? And we're going to look at a new technology, something called Lance, that is set to completely change the game by tackling one of the biggest roadblocks holding back truly personal AI.
I mean, think about it for a second. Have you ever wished your apps could just, learn and adapt to you without having to send all your private data up to some server in the cloud? Like, why doesn't your keyboard app learn your weird slang? Or why doesn't your photo app get better at spotting your friends in pictures over time?
Well, the short answer is it all comes down to a massive hurdle. It's a huge memory problem, and it's what's stopping powerful AI from actually learning right there on your device.
So right now, we're stuck with this trade-off, right? You've got this super powerful AI that lives in the cloud, it's adaptive, it's smart, but it needs a constant internet connection and, access to all your data. Then you have the AI on our devices. It's fast, it's private, which is great, but it's basically static. It comes pre-trained out of the box and pretty much never learns anything new.
Okay, so what's the deal? At the very heart of this whole problem is the learning process itself. It's a thing called backpropagation. Now, this is the fundamental algorithm that lets an AI learn from its mistakes, right? It makes a guess, it checks how wrong it was, and then it sends a signal backward to adjust itself. Simple enough. The problem is, this process is an absolute memory hog.
And here's why it's such a hog. For that whole correction process to work, the AI has to remember everything. I mean, every single calculation it made on the way to making its guess. It has to keep a complete record of its entire thought process. This huge pile of temporary data, that's what we call activations.
And this is where it gets crazy. Just look at the scale of this problem. Storing all those activations can take up to 10 times more memory than the AI model itself. 10 times! So on a small device with limited memory, like your phone or your watch, yeah, that's just a non-starter. It's impossible.
Now, obviously, people have tried to fix this before. This isn't a new problem. But all the previous solutions had major drawbacks. They were either way too slow because they had to do all this extra math, or they only worked with these very specialized, uncommon AI models. Basically, they just created way too much extra work for your device's little processor to handle.
All right, so that brings us to the breakthrough. Enter Lance. It's a new framework that takes a totally different and frankly a much smarter approach to solving this whole memory crisis.
The researchers behind Lance started with a really simple but powerful question. They said, look, instead of wrestling with this massive, messy pile of activation data every single time the AI learns something, what if we could just find a small, reusable, super efficient summary of it? Kind of like creating the perfect cheat sheet for the learning process. And that's the core idea behind Lance. It all starts with a one-time calibration. It looks at just a little bit of data, only once, and from that, it creates this perfect, compact summary. They call it a subspace. Then, whenever the AI needs to learn something new, during what's called fine-tuning, it just reuses that same summary over and over again. And by doing that, it saves a massive, massive amount of memory. And that is the key difference. See, older methods had to do this really expensive compression step again and again and again for every single step of the learning process. Lance, it does it just once, right at the very beginning. That one-shot approach is what makes it so ridiculously efficient.
Okay, so it sounds great in theory, right? A super elegant idea. But the real question is, does it actually work in the real world? Well, the results are, honestly, they're staggering.
Get this. In their experiments, Lance cut the memory needed for those activations by up to 250 times. No, that is not a typo. 250. Let's look at what that actually means in a real test.
This is what's so incredible. It's the trade-off, or really the lack of one. The standard way of doing things, full backpropagation, needed over 61 megabytes of memory to hit about 77% accuracy. Lance got almost the exact same accuracy. We're talking over 75%, but it only used a little over 1 megabyte of memory, from 61 down to 1, with basically no loss in performance. That is a total game changer.
But wait, it gets even better. The benefits don't stop with just memory savings. Because of its unique design, Lance also happens to solve one of the other huge, nagging problems in AI: how to learn new things without forgetting what you already know. So let's walk through an example. Imagine you teach an AI to recognize dogs. You show it thousands of dog pictures, and it gets really, really good at it.
Okay, great. Now you start teaching it a brand new skill, how to recognize cats.
So, after it's learned all about cats, What do you think happens when you go back and show it a picture of a dog again?
A lot of the time, it has no idea what a dog is. It's completely forgotten. The new information about cats has just paved over or overwritten the old information about dogs. This is a massive problem in AI, and it's got a great name: catastrophic forgetting.
Well, Lance has an elegant solution for this because it's working with those compact summaries of knowledge. It can store the info for the new task, the cats, in a way that just doesn't interfere with the old tasks. It's exactly like giving each new skill its own separate protected notebook. The notes for cats never get mixed up with the notes for dogs.
This ability makes Lance an amazing tool for something called continual learning, letting our devices learn new skills over their entire lifetime. And again, look at the numbers. It gets you similar accuracy to other fancy methods, but at a tiny fraction of the memory cost. I mean, look at that difference on the chart. A previous method needed over 22 megabytes. Lance needed just over 2. It's not even close.
Okay, so let's wrap this up. Let's bring it all home. What does all this actually mean for the future of the devices that we use every single day? Well, a technology like Lance really paves the way for a future where the AI on our devices is way more personal, way more private, and can actually adapt and grow with us over time. We're talking about your phone learning your daily routines, your smartwatch adapting to your specific fitness goals, all happening right there on the device, without sending your private data anywhere, and, crucially, without just destroying your battery life.
This is what makes Lance such a practical, real-world solution for the next generation of smart, on-device AI. And really, the big takeaway question for all of us is this: what new possibilities, what incredible things could our devices do if they could finally learn and adapt with us for an entire lifetime?